Hello everyone. In this video, we're going to talk about two very important metrics uh, of covariance and correlation. And what we're going to talk about is how to calculate covariance and correlation for two random variables and reflect on the concept of independency between random variables and how would covariance and correlation look like for two independent random variables. So consider that in any random experiment, you might be interested in multiple random variables. Let's say that you consider a commercial flight. These are all different random variables associated with that random experiment. Number of men on the flight, number of babies on the flight, total weight of passengers on the flight, and total weight of luggages on the flight. These are all random variables from one flight to another. These four change randomly. And a lot of time in our calculations in the past, when we were calculating probabilities, we were assuming independency between a lot of these random variables. It basically means that they have no effects on each other. These random variables are independent of each other, and then that really simplifies our calculations for probabilities. But if they're not independent, or if you want to check whether they're independent or not, these two metrics help us to figure that out, covariance and correlation. So we're going to talk about these two metrics and how they're helpful to understand the relationship between two random variables. So covariance, let's start with that. Covariance measures the linear association between two random variables of x and y. And in general, we have positive covariance and negative covariance. And positive covariance is when the relationship between those two random variables of x and y are forming a positive slope. So imagine that you are graphing x versus y. And it looks this way when you plot your data, essentially. Let's assume that x is temperature, right? And y is the sales of water bottles, right? So when temperature typically goes up, the sales of water bottle goes up. In that case, your graph is going to look like that. And that means they're having a positive covariance, meaning that the relationship is when this one increases, the other one tends to increase. And then we have a negative covariance, which you probably can guess how would that look like when the relationship is indirect. So you have x here and you have y here. These two random variables have a negative covariance. A good example of that is price of any product and then the sales of that product. When price goes up, typically sales goes down. In those cases, you can say that price and sales have a negative covariance. When one goes up, the other tends to go down. And then we have independent random variables when they typically have a covariance of 0, or very close to 0, which means you basically see no pattern in the relationship between those two. This is a very good way to figure out if two random variables are independent or not. Very similar to covariance, we have correlation. Correlation, which we showed with rho hat, also measures the linear association between two random variables. But the good thing about a correlation is that it's dimensionless and it's between -1 and 1. So it changes in that range between -1 and 1. Let's assume that here is -1, the absolute minimum correlation that you can ever see, and +1, which is the perfectly positively correlated situation. And in the middle, you have 0. For the positive side, you essentially have that relationship between two random variables. And for the negative side, you have the indirect relationship between x and y. As you get closer to 1 and you get closer to -1, the relationship becomes more positive, which means your line is going to get more straight and more following a straight line as you get closer to 1 and -1. The interpretation is essentially the same as covariance. You have the positive and you have the negative. And when you have two independent random variables, your correlation is equal to 0. As I said, the good thing about correlation is that it's between these two numbers. So +1 shows the most positively correlated situation, as opposed to -1, the most negatively correlated situation. How do we calculate these two, covariance and correlation? As you can see here, covariance between two random variables is essentially a calculation of some expected values. And once you get the covariance divided by square root of multiplication of variances is going to give you the correlation. How do we calculate variances? Here is just a reminder formula for calculating variances. We're going to look at one example in the next video.